Here all. So here we have got our question. The question says that fx is equals to this function when x is less than 0, this a when x is equals to 0, and this function when x is greater than 0. So this function has been divided into three expressions. Right? And the question is that fx is continuous at x equals to 0, then find the value of a and b. And here we have got four options. Obviously this is an multiple correct choice type. Yeah, more than one correct options will be there. So let's go with the first thing, that if this function is continuous at x equals to 0, it means that definitely the left hand limit for this function will be equal to this value a, and the same value will be equal to this right hand limit. So let's check it out for this part. Limit x tending to 0, 1 minus cos 4x by x square. Okay. Now we have one formula, cos 2x is equals to 1 minus 2 sin square x. Now what if I write this 2 sin square x in this side, and this will become 1 minus cos 2x. Now what if this 1 minus cos 2x, if it becomes cos 4x, this 2 sin square x will become sin square 2x. So in place of 1 minus cos 4x, I will simply write 2 sin square 2x, but I will write it as sin 2x into sin 2x. Why? Because so that I can do this operation, right? Because when something is tending to 0 and it is under sign, then the same thing, if the same thing has been divided like 2, here I will multiply it with 2, and here I will also multiply 2. If here I will multiply 2, here I will also multiply 2 to keep it neutral, the function same. Now what? This sin 2x by 2x will become 1. This sin 2x by 2x will become 1. And we will get the value of the limit as 2 into 2 into 2 as 8. Now this is what? This is the value of the limit when x is less than 0. Now definitely, since that is continuous, this value should be equal to this a. So ultimately we have got what? We have found the value of a, that is a is equals to 8. Now let's go for the options. We can see that this C option is correct. Okay. Now we want to work with this part. Limit x tending to 0, x to the power 1 by b whole divided by root under 16 plus root x minus 4. Now you can see that this part of function gives us a hint that what we should do is to rationalize this. Now to rationalize, I'll multiply this in the numerator and as well as in the denominator. What? Its conjugate. Multiply this at the numerator and as well as in the denominator, plus 4. Now it will become limit x tending to 0, x to the power 1 by b into this root 16 plus root x plus 4, and this will become a minus b. You can see this is what? A minus b into a plus b. So the formula is a minus b into a plus b is what? A square plus b square. So this square minus 4 square, and once we are squaring this, what will happen, that the root will automatically get removed. So I'll get 16 plus root x minus this 4 into 4, 16. Okay. Now I can simply cancel out this 16 into 16, and since this root x is nothing but x to the power 1 by 2. So I am left with limit x tending to 0. Now let's write it as x to the power 1 by b minus this 1 by 2, because this is in the denominator. So power will get subtracted, and this root 16 plus root x plus 4. Now one can easily see that upon putting directly substituting the value of 0 over x, this won't create a problem. This won't create a problem because this won't be any indeterminate form. I can simply see that this will become root 16 plus 0 plus 4, which is what? 4 plus 4, that is 8. So we have got our 8, that the value of the limit which we have calculated right now, the value of the limit, we have got it in this part only. So this part must be equal to 1, So for this to be equal to 1, this part should be equal to 0. 1 by b minus 1 by 2 should be equal to 0. This means that 1 by b is equals to 1 by 2. Now reciprocal, now if we reciprocal both the sides, we'll get b is equals to 2. This is our answer, b is equals to 2. Let's check out for the options. It says b is equals to minus 2 and this says b is equals to 2. So we have got C and D as our correct options. So hope you have understood. Thank you.